So just giving the audience a second to settle down or move on to the next masterclass. As we're approaching the end of day one, I want to introduce our next keynote speaker. It's Andrew Bennett, the CEO of Driivz, and on the slide it says Evolve. He's going to be talking about building a resilient future, the essentials for ensuring EV charging network reliability. So welcome, Andrew. Welcome.
Good afternoon. Hi, everybody. Yeah, it's the 5 o'clock spot. That can be a little bit difficult. I used to have a mentor, a boss, who would say, if you're speaking at a conference, you don't generally want to speak when you're the last person holding off the happy hour and beer. But he said also at the same time, it's better to be the last person before the beer than be a speaker while people are drinking beer. So that's always been my mantra. I want to talk a little bit today about network reliability and some of the things that we are thinking about as an industry to ensure higher reliability. And I want to maybe take a little bit of a different approach here and talk about how energy management ultimately becomes a really, really important part around the security of our charging networks. So real briefly, give you a little bit of an overview of who we are as a company. Maybe a few market observations. I know you guys have seen, at the end of the day, a lot of different market observations, but at least a few that we think are important as they relate to this topic. And then kind of dive into this idea of resiliency and where energy management plays into that. So real briefly, who we are as a company. We're part of this larger corporation by the name of Vontier. Vontier is a publicly traded company in the New York Stock Exchange, and they've been around for a while, about $3 billion in total revenue. Vontier has a long history of different companies that have been very much focused in ICE technology, internal combustion engine technology. So if you see there at the bottom, companies like Gilbarco Veeder-Root today build something like 65% of all the gas pumps in North America, same percentage here in Europe. DRB builds car washes. But about 5 years ago, the company stepped back and thought about their portfolio, and of course thought about the direction that the industry was going, and started to acquire companies and put them into a set of groups here that we think of as alternative and sustainable technologies. And so today, I have the opportunity to run this Evolve business unit, of which both Driivz and Sparkion are part of. But we also have other business units focused on sustainability. So Angie, as an example, is one of the world's leading producers of hydrogen and hydrogen fueling solutions. So really all around changing our corporation to be more ESG focused. So within Evolve, there's really two companies that we focus on and two things that we really work on in the industry. The first is Driivz, who I think probably many of you have heard of Driivz. Driivz focuses on building the software that allows CPOs to operate their networks. And so that's all the software that allows for the billing, for roaming, essentially to look after the health of those networks and allow CPOs to go and run their businesses and to be profitable. Within Sparkion, and if you guys have a chance to come visit us, what you'll see is a hyper-intense focus on localized power and energy management. And what I mean by that is software and both hardware that's designed to think about how the flow of electrons are taking place at an installation and to optimize that. So in some ways, when you think about the two sides of our company, Evolve, one side very focused on allowing CPOs to go run their business and make money. And then the other side, around energy management, how do those very same CPOs manage their costs and reduce their total cost structure so that they can be more profitable? Together, that's what forms Evolve today. So Driivz, of course, has been in the industry for a long time, I think over 12 years at this point. And Driivz's focus has always been to build very modular, but also very scalable software. And that's really worked well for this company because over the years, it's doubled and doubled and doubled pretty much every year. One of the decisions the early founders, and I don't know if Doron's still in the audience, Doron Finkel was our founder, made really early on was an extremely important one. And that was that we were going to make software that was designed to integrate with other systems at CPOs. I know that sounds kind of trivial, but you could build software that was designed to be shrink wrapped. They chose not to do that. They chose to build software that would work with existing systems. And that's why you see all these logos on the right-hand side. These are the largest CPOs in the world. And the reason why the largest CPOs in the world use our software is for that reason. Not only was it designed to be scalable, but we knew they had existing systems and subsystems that we had to work with. And so philosophically, that was always our approach to the market. Well, here we are in 2024, almost 2025, and the growth has been incredible. We are now on the platform not managing thousands of chargers, but hundreds of thousands of chargers. The growth has been fantastic. The growth, of course, has really been built on the CPOs that largely are in this room that have used the software and are growing at a really fast rate. That means over 1,000 different type of chargers worldwide, 30 countries worldwide. But the thing that's really cool is when you start to think about the impact from an ESG perspective, 530,000 metric tons of CO2 avoided. And then the number that I find really compelling today on just our platform, supporting what you guys do, we're at over 700 gigawatts of total energy delivered. That number is starting to become really, really material. So most of you guys know what a charge point management system does, a CPMS, so I'm not going to go too much into detail. But when we think about the software and how it has to work for the industry, we, of course, think about that operational layer. What does a CPO need to be successful? How do they manage their assets? How do they deal with dispatching folks to go deal with problems? And from e-mobility provider, how do they also support complex things like billing and roaming? And then all these vertical business units underneath that, I think most folks are really familiar with that. And then, of course, we think about how that ultimately affects the driver's experience and how they think about consuming your product, which is charging. And then underneath that is kind of what I want to talk mostly about today, is the things that are starting to happen at scale around complex energy management to ensure uptime of these charging networks. So first, a couple market observations. Like I said, I know you've probably seen dozens of these today. This is from BNEF. But often as a publicly traded company, we get asked questions. There'll be an article about the slowdown in EV sales, blah, blah, blah. But what we ultimately know is a slight slowdown in that inflection point of sales isn't going to have much of a difference on the expansion of these networks. So in the United States, of course, you guys can tell from my accent, I'm from Colorado. Very, very strong growth, still 32% CAGR year over year in terms of those chargers, which is pretty phenomenal. In Europe, slightly slower, about 20%. But of course, the baseline in Europe was a lot higher. So if you've been to the United States anytime recently, you guys realize we're not 2 years behind Europe. We're probably more like 8 years behind. And actually, the charging experience feels more like 15 years behind. But put either way, when you think about what's about to take place in the United States, if we're to keep up with that demand, just the new chargers and the way sales are going, we're going to need roughly 4 times as many chargers within the next 2 years and roughly 8 times to keep up with that growth by 2030. So no matter what, very, very strong growth in this industry. The last bunch of speakers did a great job on this, so I don't feel compelled to spend too much time. But again, the use cases that we're focused on today as an industry are really around these four things: fleets, that office and MDU setting, destination charging, and then of course on the go. And I just wanted to point out something here, because when we start to think about this energy problem, it obviously exists no matter which one of those use cases you are, but you do get a sense for how much more pronounced, how much more significant it is for DC fast charging, which of course shows up in two primary use cases: on the go, obviously, and then fleet. And if you look on the right-hand side here, most projections say that EV charging will be responsible for about closer to 400 terawatts of energy consumption by 2030. That number is absolutely enormous in terms of total energy consumption. And so therefore, when you break that down, the two big contributors are going to be on the go, and then what fleets are just now starting to produce. Big, big numbers. I'll give a little bit of a US context, where the grid over the last 10 years, 20 years, has really been only, the demand side of that has only been growing at about 2%. So you're talking about almost an order of magnitude more electricity generation is going to be needed to be successful. So jumping into the reliability and scalability part of the conversation, this is sort of table stakes. Everyone here in the room does this. This is what we do within a CPMS. We're constantly looking after the network health, right? Trying to determine if there's any problems and trying to deal with those problems without any human intervention. So often you'll hear us talk about things like self-healing algorithms. Well, that's a sophisticated way of saying we're using software to fix a problem on a charger without ever having to send a human being out. So a lot of what we do inside of a CPMS, of course, is oriented towards that and getting higher reliability. But I want to talk a little bit more about the energy side of that equation. Because again, you could have the best chargers, you could have the best software network running there, but if you have network constraints from an energy perspective, it's going to be really hard to charge cars. One thing we know today, that if you think about managing that energy consumption actively versus just letting it go, right? Letting people charge whenever they want with no active management, you're going to be able to charge about 6 times more cars in that same period of time if you're actively managing your energy consumption. So that's a pretty big number, and for those of you that are running CPOs, you know that that's going to result in real cost savings and actually increased revenue. Lots and lots of complexity at the site level, and many of you deal with this on a daily basis. Today, we have all sorts of constraints: physical constraints, energy constraints, things that take place if you're in a parking lot or at a campus. And thinking about how do you take advantage of other energy sources like a battery or solar becomes more and more complex based on how that installation is set up. So when we talk to CPOs and we spend time trying to think around what are the real business drivers, what are the compelling reasons to care about this, it breaks down into these 4 main categories that you see there on the right. The first is, can we reduce cost, right? So obviously if you've got peak power, you're paying more for electricity. That's not always going to be the case that you can pass that cost on to your users. So mitigating that and reducing peak power is a huge, huge driver. Nobody wants to put in a whole substation, right, at their charging area. That's very expensive. If you're moving and putting in large transformers and having to invest there, that's a huge upfront capital expense. But then the next category that is becoming more and more pronounced is around just resiliency of the network. And this is a big deal depending on where you're at. In Europe, you guys, you get to, I would say, enjoy one of the highest, most reliable electric distribution systems in the world, bar none. You guys have looped networks, you have pretty high voltage, and while in the Nordics, you're certainly getting constraints on a feeder by feeder level, it's relatively insignificant. You don't experience network outages like much of the rest of the world does. But in the United States, as an example, which has a first world economy, we have a lot of outages, right? That network is not that resilient. In the US, we have what's called a three-phased radial distribution system. Imagine a leaf, with like the veins going out on the leaf, spokes, right? So it's extremely vulnerable to outages. In Europe, everything's looped, it's connected. And so not only is that a three-phased radial distribution system fundamentally weak, it's also overhead, right? Every time one of my European colleagues comes to the United States and they look at all the poles and the ugly wires, they're sort of shocked, right? But that's how the distribution system was built, and it kind of sucks, right? So we have a lot of outages in the United States. That's why we have statistics, MAFE, CAFE, SAFE. These are reliability indices that are designed to tell you how good or how bad your electric network is. And it's not that good. So as this rollout continues in the United States, this idea of electric resiliency is much more pronounced than it will be here in Europe for all those reasons I just mentioned. ESG goals, without a doubt, one of the biggest drivers we hear today around why do we want to do more localized energy management? Because we also want to use things like solar. We want to make sure that the energy we're using to charge cars is in fact green. And then obviously earning revenue is great. We've got a whole bunch of customers today that are starting to play in those ancillary markets. The more localized control of energy you've got, the more you can go bid on that electricity. So things like FFR and thinking about the frequency changes on networks and taking that reserve capacity and going and making money on it. So it's sort of the opposite of number one, right? It's not about deferred costs, it's actually taking that capacity and going to do something with it. So those are really the four things we hear from CPOs in terms of their drivers. And then as we think about what are those on-site things that are really, really important to them, it comes down to a whole different list, and it varies depending on the type of CPO. But again, what you're trying to avoid is localized problems like tripping a breaker, right? You're trying to make real-time decisions based on the shape of the load curve and where you can essentially reduce your cost and or make money. So lots and lots of use cases, and we could spend a lot of time on any one of these. Today, what we hear from our customers is it's great. They like to manage and think about their energy consumption in the cloud and at many sites, but they also like the localized control at a single site. And so often that involves putting a local controller there, a physical device, it's a computer by and large, that connects to all your variable load, right? That allows you to charge and discharge a battery when it makes sense. You want to discharge a battery, right, when the cost of energy is really high, and you may basically charge that battery when it's low. You want to be able to ingest all the solar energy that's at your capacity. And then you want to be able to effectively think about each one of those use cases and how you can effectively run that local site. It's a combination of cloud-based software, and it's a combination of localized control. And for those of you that are into this sort of thing, one is cloud and open standards, and the other is things like Modbus. When you need to throttle back control on a device, in order to hit an FFR response rate, you could be dealing with 1 second or sub-millisecond response times. You're not going to do that from the cloud. That's just not what that cloud software is designed to do. Ultimately, I think my one sort of point here is no matter what you decide to do from an energy management perspective, you already know what all the drivers are, you know why you want to do it. Put something in place that doesn't pigeonhole you into a single business case, right? Something that doesn't make you just think about the charging or discharging of a battery. You want to be able to think about all these things in concert. And then ultimately, we've got lots of our CPOs starting to do this today. As you have more and more sites come online, you can start to think about this in aggregate. So it's a fancy way of saying you become an aggregator or a VPP. When you start to think about the amount of energy that these CPOs are consuming and we can go back to that previous chart, 400 terawatts of energy consumption. That's a lot of energy. And so why not go make some money off of it, and why not reduce your cost? Because you're becoming really, really, really big energy consumers, and therefore you should have better buying power and you should have better selling power. It's just kind of logical. So, one more slide here. I just maybe I'll leave you with a couple thoughts. This is a great example of a Circle K site. I feel like every time we take a photo of a Circle K site in the Nordics, it's always got about 2 meters of snow around it. But what Circle K is effectively doing is they're thinking about the energy consumption at all of their sites. And in one of the more innovative models that I've ever seen used, they don't think about energy management as a big project for every site. They're basically putting in the telemetry at all their charging sites. They want to know how much electricity is the car wash using, how much electricity and when is it being used for chargers or for my convenience store. And then they're putting in localized batteries and they're putting in localized solar to optimize that. But what's kind of cool about this, stick with Circle K for a second, is they're also putting in that telemetry at lots and lots of sites that don't yet have batteries and don't yet have solar, because the idea is if you really do have a discrete and granular view of your energy consumption at all your sites, then you can decide over time, based on data, where are you going to make those other capital investments, right? You might not necessarily need a battery at every last station. So with that, I guess I'd kind of leave with just two closing remarks. The first is this, because of the amount of energy consumption that's taking place, we no longer think about a CPMS software as just running the CPO back-end systems. We think about it also as helping them save cost and go make money when it comes to actively managing their energy consumption. Thank you. Sure.
Thank you so much, Andrew.
I got us back on time.
We have, put it on the, we have a few minutes left, very few. So please, if you have a question, raise your hand. I'll start with one, because I think integrating charging infrastructure, energy consumption through charging into the grid is a really great talent. You were talking a lot about scalability and that you operate hundreds of thousands of charge points across country borders. Coming from Germany, we have a lot of distribution grid operators. We also pay a lot of money for energy not being able to be transported across Germany. So we have great need for solutions. But how do you actually scale a product for all these different markets that are highly regulated?
Yeah, that's a great point. It's interesting because the German utility market is actually very similar to the US. In the US, we have 3,420 different utilities, right? It's a lot. And Germany has hundreds with the municipal utilities and the large, we call them IOUs or investor-owned utilities. At the end of the day, it's electrons. You're sort of solving the same problem from a technical perspective. Now, the regulatory environment where I see that having probably the biggest impact is when you want to then play in the wholesale markets and monetize that. That variation there is huge. It's huge in Europe. Every country is obviously regulated differently. So if you want to play in an FFR market in one country, it is very different than another country. In the United States, we're essentially regulated like 50 different countries. So in the United States, every state essentially has its own set of regulations. So it does make, when you start to do cross-country or cross-state type things like this, the incentives can be different, the monetary policies can be different, but the technology is the technology at the end of the day. Yeah.
So I have lots more questions on the energy side. So continuing from that, how attractive is the European market for you with respect to also trading flexibility and sort of the energy sector?
Yeah, I think, we have customers here several here who are actually actively doing this and bidding. You know, if you guys have ever looked at sort of the bid packages, for instance, in FFR, there's like 8 different things you can bid on, 8 different packages. It depends on how much energy you want to give up, defer, right? And then you have to guarantee that you actually can do it. And if you don't do it, there's penalties associated with it. You know, my sense is that the monetary gain on these things is still relatively small.
Yes.
I've seen some of the data when you're actively bidding into the market. I think the bigger benefit is in avoidance still, right? You have a demand response event. You are throttling back the level of, that you're charging, which we're actively doing with a lot of customers today. So it's mostly invisible to a user, when that happens. You're charging your car, maybe you were charging at 150, kilowatts, and you'll see a little bit of a sag. That could be the active system actually throttling that back during a very small period of time. The benefits for that management are a little bit higher today than the benefits for actively bidding in the market. But I think that's going to change. As energy gets more and more scarce, I think that the monetary gains will get larger over time.
Anyone? What do you think would be the next evolution step? So we haven't talked about feeding electricity back into the grid, but might be a natural one.
Yeah, V2G is going to play a role here as well. I think it's kind of silly to think that V2G is going to take place with on-the-go charging. I can't imagine someone saying, boy, I'd like to drive out to that station and sit there for 2 hours while I discharge my. I've seen companies come up with value propositions there. I think it's fairly unrealistic. What we're seeing, though, with larger fleets today is that's where it becomes really, really viable. And it's interesting because, again, so much of what we do in Europe, and we've been waiting for years for the United States to sort of wake up. And because of the NEVI funding that went in place, by the way, a lot of people have asked me this week if there's a change in administrations, will that funding go away? And the answer is no. That stuff gets acted on by Congress. It gets locked into law. So even if we have a major change in the presidency, that money still will get spent. Most, I think, of the V2G stuff that will take place in the United States, similar to Europe, will be with larger trucks, larger fleets where you have more capacity and you have more stagnant capacity where you can take advantage of it. School buses today are the number one thing. Yeah.
That's a use case we hardly even have in Germany. I still hope that we'll catch up. But thank you so much, Andy.
Thank you.
You're going to be around later on?
Yeah, of course. We have a booth. We'll be here all.
There's a booth. So if there are any questions, but thank you for now.
Thank you. Appreciate it. Thanks.